Hello everybody, and welcome to another episode. This is Michael, KE4EST. And as you can see here, I've got this kind of on its side here. This is the Precision Apparatus Company's E-400 sweep generator. Which, you know, come out Paco later, things with Paco on them. And the reason it's like this is I've already started the teardown. I already did a video. I did a teardown video, went through it, and got it here ready. Even got some capacitors out here, ready to start recapping this and getting it ready. Let's pull the video up and synchronize the audio and do all that and get started on video editing a little bit on this, on the first, you know, the teardown of it. And the video is messed up. I don't know why. So I have put in a new SD card and we're going to try this again. I started to put everything back together and pretend like it hadn't even started yet, but then we kind of lying a little bit because I like to take these apart. It's always really neat to go into these things and see what's in them and see what's, you know, not only what's in them and makes them tick, but, you know, what's happened to them and what's not supposed to be there, or some bad soldering job or whatever, you know. So I have already started tearing into this one. Like I said, I already did the video, but we'll go over it. Just really don't want to set like this. Good. I'll have to kind of hold it. See that? And I don't want to put a tube down there. I don't want to hit. But like I said, this is the E-400. It's a sweep generator. Came out around 1950, and they made this model here up to about 1954. Best I could do in my research. And then they kind of did some tweaks to it. Like this has got a fuse holder here. They had a blanking switch they put here, but they also changed the look of it. All the knobs, everything's the same place. You can look it up. And even it's still under like E400, maybe C or something like that. Everything's the same, except if they did a different paint scheme and whatever. But, and I do have this. This goes here. Yep, turn it around the right way. And I've already started cleaning on that. You can see how, catch the light just right there maybe, I don't know. How scuffed up it is a little bit, but it was pretty scratched up. And I went through and buffed a lot of that out. And this here's a piece of plastic or lucite. But anyway, so this is used a lot, you know, in like mainly like in IF alignments and things like that. You can use it for other things, but you know, and it even says over here FM, television, AM for like FM receivers, television receivers. Back in the day, you got your frequency range here, where you want to set your frequency, and this goes up to. Technically up to like say 240 megahertz. It says 240 megacycles. But what I really need to find something that might work right there. It's a little aimed forward a little bit, but maybe you can still see it okay. But anyway, so you set your frequency where you want. But it'll go up to 480 megacycles with harmonics. This thing's really rich in harmonics the way this thing's set up, the way the circuit is inside. I'll start up here, sweep with. You can set this, say wherever you want it when you got the thing there, whatever frequency you want. So you set it for 10.7 megahertz for an IF frequency. And then you'll need to have a crystal in here, which this has got a place for 4 crystals, or you can have an input here from a signal generator. And then you set your sweep range over here. And this is 0 to 1,000 kilocycles or 0 to 15 megacycles. Say you put it there. And so now this width over here will go from 0 around to, well, that needs to be, I noticed this here, like somebody's really shoved that on there and tightened it up or something. And this too, when I pulled this off here, it was really pushed into that. And when you turn this, it was like grinding against that. I was like, whoa. So you got this on 0 to 1,000, and say you got 10.7 megahertz, and you want to go 200 kilocycles either side of that, or 400 kilocycles either side of that. That's what the sweep range will be. So if you get set on 200, it'll go from 10.6 to 10.8 is what the sweep range will be. And this is your band selector for different bands on here. Here's your on and off switch and your phasing control. This of course is the VFO here. And the crystal selector, and you can turn the crystal marker on and off here. And this has got dual output control. It's supposed to be precision. Your RF, set your RF level and your output control. Here, like I said, is where your input will go into. Amplitude for your crystal. Here's a couple of grounds. This one here's broke, so I'm going to have to redo that one. I'll probably should replace both of these, and I'll probably replace these here with B and C jacks. And here you can come out here to your oscilloscope, and then you can look at the pattern on your oscilloscope, so you can, because a lot of times it's better to visualize and see something than trying to line an IF up by using, you know, say a VTVM or something like that. You can get them pretty close and good enough a lot of times. If you really want it, you know, a whole lot better, you want to use a sweep generator with the signal generator feeding to your sweep generator now here into the oscilloscope, so you can really fine tune it. And then of course your next thing up would be, you know, getting a spectrum analyzer, a really good spectrum analyzer. But that's what they used back then, and this is it. So let's take that. I'm going to go ahead and put this on its side now. Bring it around here. So here's the power supply section. Got 6x5 here and a O. Probably, let's see, O. Trying to see if I can see that. It's probably a O. Probably a 3. I can't remember. Yeah, OC3 voltage regulator. Here, and in the power supply section, there is a can down in here for your filter can. That's going to have to go. You can see the two capacitors here. These wax capacitors, they got to go. They just and somebody asked me, you know, why do you just replace all of them? Why don't you just test them? And when it comes to capacitors at this age of equipment, they've got to go. I mean, you just change them out. There's no, well, maybe should I just get rid of them? Now other things you can't. Now I do troubleshoot and go through. I just don't want to start replacing everything. But the kit, those old capacitors, they just got to go. Now, like up here, this here is a mica capacitor. It can stay. Them hardly ever fail. I'll check it out. But there's another one here. These little dog bone capacitors here, they're usually good. They can stay. There's another capacitor down here. It's got to go. I was looking at the resistors, and I already, of course, said this when I tried to record this the first time. These are actually Allen Bradley's style, so they're probably good. We'll test them. Except for this one down here, actually kind of looks like a roundy, so it's kind of weird actually. Looking at it really close, it's kind of got some dust all over it and dirt or something, but it looks like it's actually got a little bit too hot at one time. That actually probably is Allen Bradley, but we'll test them all anyway. These are your chokes here. These are just RF chokes to keep you know, these harmonics and stuff getting back onto the power line, or from the way this thing's set with the beat frequencies. I mean, that's pretty much it there. There's your crystal oscillator section here, and your crystal oscillator tube, 6C4. This thing's got plenty of 6C4s in here. So, and then this here is an interesting setup. This is on the thing here to keep it from, you know, vibrating or whatever. This here is kind of like a speaker. It vibrates the thing kind of like a voice coil, but not quite, back and forth, 60 hertz coming off the line frequency. And that's why this here is on these, you know, cushioning system here, dampening system, so it don't vibrate up against this with the other, you know, metal around it. And that is what gets your sweep going back, you know, back and forth, back and forth, back and forth. That's kind of an interesting system. It took me a while to figure that one out, but and then inside of here, I took this off another video already to show. It's just your attenuators there, and your output, your main output here. So, I mean, there's not a whole lot there. The case of it, I've got the case, it's off. I've got it sitting over there. It's just a nice heavy duty case. Needs a little cleaning up. The case itself has a RFI filter box inside of it with a couple, let's see, I think there's 4 capacitors in it and 4 coils. Where the line comes in, it goes through that, and the line comes out. So, and the capacitors in there look like these here, just smaller ones. And like I said in the video, of course I keep it now, but the other video I was like, I bet in this can, before I take it off, it's kind of like this right here. It's this copper plated steel here. So I take the screws out and pop this can. It's going to have waxies in it, probably across the, you know, line, and of course they do. So that's automatic right there. If them things go out, they're going to short and cause all kinds of problems. So I'll be replacing those, you know, with safety capacitors. But that's pretty much the circuit there. Not a whole lot more to show you. Everything's opened up here. There's actually a cover that goes over this here. In fact, let me get that. Let's see here. This cover here, and it slides over. Let's see which way, get it the right way here. And go this way here, and it'll slide over this like that. So more RF shielding, and there's 3 holes in the top of it there, so that you can go in and do some of your alignment on this here with these variable capacitors in here. You can kind of see there's a microfilm capacitors, 1, 2, 3, 4. With these capacitors here, there's 1, 2, 3, 4. And then put your shielding on, and you go through the holes to get this one, and this one to make your final adjustments, so that it's, you know, got the RF shielding in place. Because once you remove that, make adjustment, put it back on, it's going to change. You know, the metal being close and stuff is going to make some changes to it. So you don't want to do that. But that's pretty much it. Hate that you missed the opening of it, but there's everything in it. We got 2 tubes in the power supply, 1, 2, 3, 4, 5 tubes there. We should do, yeah, there's a 6 tube over there for oscillator, for the crystal oscillator. So that's it in a nutshell. That's the unit, and I'm going to get it all cleaned up, replace these capacitors, and then we'll go through it and see if I can find a schematic online, kind of maybe go over that a little bit. I found one that's kind of hard to read, so I don't know if we'll do that or not on this one, but we'll try and see. And just trying to think if there's anything else I could probably, as soon as I hit the stop the recording button, I go, oh yeah, I meant to tell them this, but I can't remember. But there's the E-400 from Precision Apparatus Company. Thanks for watching. This is Michael, KE4EST 73.